Okay, sir. Start, sir.
Yeah, okay, sir. Yeah. Good morning, children. This is the last class, I think so, in the periodic classification lesson. Might be today we are going to complete the lesson, I think so. We'll start what will happen at the end of session. If it will be finished, this is the last class, otherwise we'll take another class itself. So probably we have completed the periodic properties of what atomic size, metallic property, and valence of electrons, how they have variated in groups and periods, increasing, decreasing based on what factors, atomic size, metallic property, valence, how they have varying in the groups and periods. So those are all we have discussed. Ionization enthalpy definition also we have given yesterday. Once again, we'll start from ionization enthalpy onwards. Just we'll see the definition and how they are varying in groups and periods. We will discuss right it now. Already we have discussed yesterday ionization enthalpy definition. It is the form of energy in order to the required energy which is required to remove an electron from the neutral gaseous atom. In order to remove an electron from the neutral gas atom, how much amount of energy is required? That energy we can call it as ionization potential or ionization energy itself. If you'll observe here, X is the neutral gaseous atom. X is the neutral gaseous atom is here. Once you observe, children, clearly. So this is the X gas atom. Then, well, we are removing an electron, that is plus E minus in the form is that. And when we are removing an electron from a gaseous atom, that X is becoming gas, X plus cation in the gaseous form. This is called as first ionization energy. Why? Because we have removed only one electron at that place. Merely, the ionization enthalpy is expressed in units of kilojoule mole inverse, or we can call it as kilojoule per mole. We can define the second ionization enthalpy as the energy required to remove the second most loosely bound electron that itself. So, from the cation which it is formed by removing of one electron in the earlier step, which it is formed earlierly, X plus cation, monovalent, unipositively cation, that is, from that unipositively cation, we are removing one more electron. Because of that reason, a dipositive cation is formed. This is the second electron we are going to remove from the unipositive cation. That is called as, we are removing second electron. Because of that reason, it can be called as second ionization potential or second ionization energy. So, how many number of electrons we are going to remove? That it is called as that particular ionization potential. The first electron we are going to remove, first ionization potential. Second ionization potential, second electron we are going to remove, second ionization potential. Similarly, always the next ionization potential energy is always higher than the previous ionization potential itself. By means what? IPE1 is always less than IPE2. That means IPE2 is greater. Similarly, IPE3 is greater than IPE2 itself. Okay. So by means what? The nucleus, these are the electrons are, when we are going to remove the second electron and the third electron, at that time what is going to be happened itself, these are the electrons are coming to somewhat towards closure to the nucleus. Because of that reason, to remove the electron, we have to use much more energy to remove the electron which is near to the nucleus. కేంద్రకానికి దగ్గరగా పోతున్నప్పుడు ఏమవుతుందంటే కేంద్రకానికి ఎలక్ట్రాన్కి మధ్య ఉండేటటువంటి ఆకర్షణ శక్తి పెరిగిపోవడం వల్ల మనం ఆ ఎలక్ట్రాన్ తీసేయడానికి అవసరమయ్యే శక్తి కూడా ఎక్కువ అవసరం అవుతూ ఉంటుంది. Because of that reason, the next ionization potential energy is always greater than the earlier itself. Okay, once again we'll see here. The second ionization enthalpy will be higher than the first ionization enthalpy because it is more difficult to remove an electron from a positively charged ion than from a neutral atom. In the same way, the third ionization enthalpy will be higher than the second and so on, like that. The term ionization enthalpy, if not qualified, it is taken as the first ionization enthalpy or ionization potential or ionization energy also we can call itself. Okay, let's observe the graph, children, once of all. First of all, in this graph, on the x-axis we have taken the atomic number. Once you observe here, these are the atomic numbers on the x-axis we have taken. And on y-axis we have taken delta IH values, kilojoule per mole or mole inverse is there. These are the ionization energy values on the y-axis we have taken. On the x-axis atomic numbers are there. Observe children in this graph, here helium on the top at the peak stage you can observe here, helium is there, neon is there, after that argon, after that krypton, after that xenon. At the peaks of the graphs, if you are going to observe, all are present are noble gases only. Observe here once, helium, neon, argon, krypton, xenon. By means what? Most of the cases, the higher ionization potentials are occupying noble gases. And if you are observing at the low peaks, higher peaks are occupied by the noble gases, and lower peaks ones we will observe. Lower peaks ones we will see. First one is lithium, after that sodium, after that potassium, and then rubidium, after that cesium. And the remaining elements are occupying the places of the lower peak, in between the lower peak and the higher peak of the graph, these lines. These are the middle elements these are the remaining elements are present. So on what basis we can explain this? Why the peaks of the graphs are occupied the noble gases, higher peaks, and why the lower peaks of the graphs are occupied these first group alkali metals, lithium, sodium, potassium, rubidium, cesium, like that. What is the reason behind of this? Once we will observe the students, lithium, sodium, potassium, rubidium, cesium are the first group elements, alkali metals. The general electronic configuration of these elements is NS1. We know that very well. By means, if you have taken sodium, it is 3s1, potassium 4s1, like 5sn and 6s1. It is not having a stable electronic configuration. That means octet configuration is not here in the first group alkali metals. So because of that reason, if that electron, that 3s1 and this is 2s1, 4s1, if the the last electron which it is present in the last valence shell, if we have removed, for example, sodium 1s2, 2s2, 2p6, 3s1, if the last electron is removed, sodium is going to get the stability. So because of that reason, nucleus also not showing that much of a tendency to attract the electron. Why? Because if the sodium will lose the electron, it will get the stability by getting of octet configuration. Potassium also, by losing one electron, it is getting the stability. By losing one electron, rubidium is getting the stability. By losing one electron, cesium is getting the stability. Because of that reason, it is always show the tendency to lose the electrons readily, easily. Because of that reason, much more energy is not required to remove an electron from the neutral gases atom of the first group elements itself. Because of that reason, these are the first group metals. And first group lo unnatuvanti elements lo electron తీసివేయడం అనేటువంటిది చాలా ఈజీ. ఆ ఎలక్ట్రాన్ పోతే కనుక వాటికి ఆక్టేట్ కాన్ఫిగరేషన్ వస్తుంది కాబట్టి easily we can remove the electrons clearly. Okay, so that's why the first group metals what are present here, they are having lower ionization energy values here. Once you observe the lower peaks everywhere. Similarly, if you are going to observe the peaks of the higher peaks of the graph, you observe all noble gases are occupying the peaks. Yes or no? Why higher values are there? Already noble gases are having octet configuration. Fulfilled electrons are present in the valence shell. That means the element is stabilized. So in order to remove the electron from the stable configuration, it is very difficult to remove the electron. So already 8 electrons ఉన్నటువంటి valence shell నుంచి ఎలక్ట్రాన్ తీయడం అంత ఈజీ కాదు. We have to use much more energy. ఎక్కువ ఎనర్జీని యూజ్ చేస్తే ఎందుకంటే స్టెబిలిటీ లాస్ అయిపోతుంది కదా. Because of that reason, those are the elements are losing the stability by removing the electron. Because of that reason, that much easily the nucleus is not accept the electrons to give easily. So we have to use much more energy to remove the electron from the valence shell of the noble gases atom. Because of that reason, we have to use more energy so that the ionization energy values for the noble gases are higher in the peaks itself. By removing, once again, we are clearly I am saying that here why we are getting lower values. If we remove the electron, they are getting the stability easily. Because of that reason, lower values. In these noble gases, if we remove the electron, they are losing the stability. That's why they won't give the electron that much easily. By using lower ionization energy values, have to use more ionization energy values. And the remaining elements which are present moderately.
They are having somewhat what nearby the electronic or nearby the octet configuration. That's why have to use moderate values of the ionization potential energy values itself. Okay, right. So this is regarding the definition of ionization enthalpy or ionization energy, and how it is in groups, how it will be lower values where it are present and higher values where it are present. By means what, once you observe first group, if you are going to observe, the values are very low, and noble gases, the values are very high itself. If lithium, if you have taken, that is the first group, that is a second group element, and after that lithium after, if you have taken the second period element, lithium after neon will be there in the second period. If you will observe, lithium is having the least value and neon is having the highest value of ionization energy. By means what? Least to highest. That means it is clearly, it is in ascending order. By means what? In a period, what? Lithium to neon, the ionization potential energy values are step by step clearly we are going to observe increasing. Once you see, lithium is a second period element here. After that, lithium to, yes, see how it is going to be increases up to neon, increased or not. So in second period, the ionization potential values are clearly increases. How? The variation we are going to observe in the period. Okay, next, factors affecting ionization energy. So here, students, this property is clearly affected by some factors. What are those factors? Once we observe, ionization potential depends upon clearly atomic size. Children, already we have discussed yesterday atomic size. So if atomic size, how it is affecting the ionization potential, let you know once. How it will be, I'll explain you clearly. If atomic size is more atomic size is there, that means number of shells are more. If number of shells are more, we can remove the electrons easily because the nucleus attraction force is less on the valency shells. If the shells are more, in the sense atomic size is more. Where atomic size is more, ionization potential is less. That's nothing but atomic size is indirectly proportional to the ionization potential. Clearly we can say that if size is more, we can remove the electron easily. Why? Because the nucleus attraction force upon the valency electrons much more is not present or decreases. Because of that reason, atomic size is indirectly proportional to the ionization potential or ionization energy itself. See, once you hear with increasing in atomic size, the ionization potential decreases due to decrease in attractive force of nucleus on outermost orbit of electrons. Okay, right. So this is about the first factor which is affecting the ionization potential itself. Let's take one example. How it will be? For example, lithium is there and sodium is there. Lithium atomic number is 3, means only 2 shells are present in that. Sodium, in that 3 shells are present. From which we can remove the electrons easily? From lithium or sodium? From sodium we can remove the electrons. Why? Because the size of the sodium is more, because number of shells are 3. But whereas in lithium, the number of shells are 2 only. So energy which is required to remove an electron from the valency shell is called as ionization potential. We know that. So easily we can remove from the third shell. Why? Because the nucleus attraction force on the third shell will be less when compared with the second shell, which is present in the lithium. Because of that reason, atomic size is increases, ionization potential is decreasing. This is the first factor. Coming to the second factor, it will be nuclear charge. So how the nuclear charge is going to be affected the ionization potential? That we will see. With increasing in the effective nuclear charge, ionization potential increases. See students, if the nucleus charge is increased, ధనావేశం అనేటటువంటిది కేంద్రకం యొక్క ధనావేశం అనేటువంటిది పెరిగిపోయింది అనుకుందాం. When it is increases, what will happen? Because of the abundance of nucleus charge, positive charge, the electrons which are present in the shells, that has been completely more and more attracted, more and more pulling is happened by the nucleus of those electrons. So because of that reason, what is going to be happened? In order to remove the electrons which are present in the valency shell, that is very difficult to remove. So where nuclear charge increases, ionization potential is also going to be increases. So what relation we are going to give to the nuclear charge and ionization potential? It is directly proportional relationship, which is nuclear charge is directly proportional to ionization potential. So clearly, atomic size is indirectly proportional, nucleus charge is directly proportional. So after that, third one is screening or a shielding effect. This is the third factor which is going to be affect the ionization potential. See once here, if the number of electrons in the inner shells are more, shielding capacity of the inner electrons on the nuclear charge will be more itself. Hence, ionization potential is decreases. Clearly, here we can observe, children, once shielding effect. Shield means nothing but it's a, I assume it as a layer. Once you can shields or screens oka tera laga ఊహించుకుంటాం మనం ఇక్కడ. So nucleus is the having a positive charge in the atom. After that, these are the shells can be acts as the screens. Exactly, shells are not the screens, the electrons, more number of electrons we are considering as screens here actually. But in order to understand, I'm saying like that. So if the number of electrons in the inner shells increases, for example, atomic number, less atomic number and more atomic number elements we have taken. In more atomic number, what will happen? Number of electrons in the inner shells are more. Electrons sankhya perigipothundi. Because of that reason, these are the electrons which are present in more number will be act as the shields. Because of that reason, so shielding capacity of the inner electrons of the nuclear charge will become more. Hence, ionization potential is decreases. When these are acting as inner electrons, inner shell electrons are acts as the shields, at that time what will happen? The nucleus attraction force is going to decrease on the outermost shell. Why? Because inner shells are present now. Those inner shell electrons are acting like what? Screens, as shields. Because of that reason, the attractive force of the nucleus and in between the nucleus as well as the core electrons, it has to be decreases. Why? Because these are the inner electrons are acting as the shield itself. Because of that reason, when the attraction force is going to be decreases on the valency electrons, so immediately, easily, with a low energy, we can remove the electron easily. So major thing we need to observe, students, especially every factor is based on what? Majorly on the nucleus attraction force. That we have to observe that where nucleus attraction force is more on the valency electrons, ionization potential to remove the energy, to remove the electrons, whatever the energy is required is also more. If nucleus attraction force is less, we can remove the electrons very easily. Here, nothing but these are the inner electrons are acting as the shields. Because of that reason, the outer electrons we can remove very easily itself. Okay, right. Next one, the penetrating nature of orbitals. As the positive charge increases, penetrating nature. Next after that, penetrating nature of a orbital. See, if we have seen penetrating, what is meant by penetrating? Entering into the orbitals. Penetrating in the sense what? Entering into orbital loki praveshinchadani మనం ఏమంటున్నాం? Penetrating nature we are going to say here. Penetrating nature, if you are going to observe here, for example, if you have taken any elements, 1s, after that 2s 2p, after that 3s 3p, then 4s, like that, the electronic configuration is going to be filled into that. Penetrating power is, for example, electrons are entered into the first shell in that orbitals, yes. After that sp, after that spd, after that spdf, like this. The first element, if you have seen, electron enters into s only. After that s after p, then after d. By means what? Where the penetrating power is more. That means in the whatever the orbitals are increases, at that time we can directly remove the electron very easily. In the third shell, s orbital electron is present, and d orbital also electrons are present. So for which one ionization potential is more? For s orbital. In order to remove the electron from the 3s, the energy is required more and more. But whereas in 3d, it will be less. Why? Because it is far away from the nucleus and penetrating power is more for s, not for d. Because of that reason, in order to remove the electrons from 3d, the less energy is required. In order to remove the electron from 3s, more energy is required here itself. So based on electronic configuration also, if you observe, electronic configuration is increases. Nothing but what? Number of shells or core electron, inner shells electrons, as well as the number of electrons, and the nucleus attraction force upon the valence electrons is going to be decreases. If the electronic configuration is less, by means of that what? Less number of electrons are present in that. At that time, definitely ionization potential is increases. By means what? These number of electrons where it was less, these are the electrons are near to the nucleus, near to the positive charge. In order to remove the electrons very easily, the electrons must and should be present far away from the nucleus. Because of that reason, so electronic configuration is increases means ionization potential is decreases. Whereas electronic configuration is less, that means having less number of electrons, we have to use more ionization potential. Nothing but it is also indirectly proportional to the ionization potentials. The last point, if you're going to observe here, so these are the 5 points. What are the ionization potential depends upon? Majorly affecting factors are atomic size, nuclear charge, screening or shielding effect, penetrating nature of orbitals, and electronic configuration. So the last points once you observe, as the positive charge on cation, increases, ionization potential increases. See once sodium plus is there, Na is a neutral atom. In order to remove the electron from that valence shell, easily we can remove it. Why? Because 3s1 if we have removed, it is going to get the configuration of 2s2 and 2p6. Stable configuration వస్తుంది కాబట్టి ఫస్ట్ ఎలక్ట్రాన్ ఈజీగా తీసేయచ్చు. లెస్ అయనేషన్ పొటెన్షియల్ మనకు రిక్వైర్ అవుతుంది. ఓకే, అప్పుడు సోడియం మీద ఏ చార్జ్ వచ్చింది? Na ప్లస్ వచ్చేసి. సో that is a cation, mono unipositive cation, as the positive charge on cation increases. ఇప్పుడు ప్లస్ ఒకటే ఉంది కదా, మరి ఇప్పుడు పాజిటివ్ చార్జ్ ఇంకా ఇంక్రీజ్ చేస్తుంది. బై మీన్స్ వాట్? Na plus is there, but actually we are increase the positive charge, means nothing but Na plus 2 చేద్దాం అనుకోండి. By means we are going to remove the second electron from the sodium. Second electron remove చేయాలంటే the configuration is what? Already when first electron is removed, the configuration is 1s2, 2s2 and 2p6. Now it is in second shell. How many electrons are present? 8 electrons are present, which is having a stable configuration. And it's not easy to remove the electron from the octet configuration. Because of that reason, we have to use more energy to remove the second electron than the first electron. That's why positive charge increasing in the sense what? Na plus kasta emotadi? Na plus 2. So because of that reason, what? Easy. When cation positive charge increases, ionization potential also increases. Similarly, the negative charge, if you are going to observe here, as the negative charge in anion increases, ionization potential decreases here itself. Okay, so that also can be explained with an example. You can take as what? Nitrogen or oxygen, like that. Similarly, now variation of ionization potential in groups and periods. How it can be explained? Once you see. In periods from left to right, ionization potential increases due to decreasing in atomic size and increasing in effective nuclear charge. Yesterday we have seen the atomic size, how the atomic size is going to be decreasing and how the effective nuclear charge is going to be increased. Yesterday we have seen. We have seen till the end of the element from lithium to neon, these are the elements electrons are going to fill in a second shell only. If you observe the lithium, 1s2, 2s1, neon, 1s2, 2s2, 2p6. That means electrons are present in second shell only. So atomic size is in decreasing because stable configuration, the nucleus is pulling the shell towards the nucleus. Because of that reason, atomic size is decreases. When atomic size is going to be decreases, what will happen? Ionization potential increases. Why? Because in order to remove the electron from the valence shell, more energy is required. Why? Because the shell is more closer to the nucleus. So this is the variation we are going to observe in the period itself. In a period, an alkali metal atom has lowest ionization potential, inert gas element has highest ionization potential. Already we have seen in the graph, I explained. In period, second period, once you observe children, lithium is here and neon is here. So lithium having the least ionization potential value and the neon is having the noble gas having the highest ionization potential value. By means lower to higher value means it is increasing or not? Lithium to so neon. That's why a period, definitely the ionization potential values are going to enhances or increases here itself. Next, after that, in groups, from top to bottom, ionization potential decreases due to increasing in the atomic size and increasing in the screening effect of inner electrons. Already we know that. For example, sodium you can take, cesium you can take. So if you are going to observe sodium and cesium, what will happen if you observe here sodium and cesium? In sodium, we are having the configuration of 3s1 here itself. Yes or no? And in cesium, we are going to get 6s1. So third shell of electron this side is here, sixth shell of electron this side is here. It is easier to remove the electron from the sixth shell. Why? Because the inner electrons can act as screens or shields. Otherwise, the atomic size is more of the cesium. Otherwise, number of shells are more for the cesium. And the energy which is required to remove the electron from the sixth shell is very less when compared to the third shell. Because of that reason, sodium can require energy ఎక్కువ, cesium can require energy చాలా తక్కువ. So because of that reason, from sodium to cesium, you can observe in groups from top to bottom, ionization potential values are decreases due to increasing in the atomic size and increasing in the so that electron gain enthalpy. See children, electron gain enthalpy, if you observe, when an electron is added in neutral gaseous atom to convert it into a negative ion, the enthalpy change accompanying the process is defined as electron gain enthalpy. When an electron is added, electron is removed, but here an electron is added to the neutral gaseous atom. Because of that reason, what is going to be happen when an electron is added to the neutral gaseous atom? Some energy is releasing there by adding of the electron, and that element is going to get which charge? Negative charge. Because of that reason, what is going to be happen? Here we are taking X gas, one electron is going to be added. Because of that reason, X is changing as X minus. That means anion. Where ionization potential case, what will happen? Element at a neutral gaseous atom is converting as cation. In electron gain enthalpy, it is changing as a negative anion itself. That you need to observe. Depending on the element, the process of adding an electron to the atom can be either endothermic or exothermic. Adding of electron process will be, it might be endothermic or exothermic. అంటే మనం ఎలక్ట్రాన్ యాడ్ చేయటటువంటి ప్రాసెస్ అనేటటువంటిది అది ఉష్ణ మోచక చర్య కావచ్చు, ఉష్ణ గ్రాహక చర్య కూడా కావచ్చు. Added to the atom and the electron gain enthalpy is negative. For example, group 17 elements have very high negative electron gain enthalpies. Halogens ki gain enthalpies ఎక్కువ ఉంటాయి. ఎందుకు ఎక్కువ ఉంటాయి? ఉండాల్సిన అవసరం ఏముంది వాటికి? They have 2s to 2p5 con 2s to 2p5 when one electron is given to the ready electrons very easily. మనం యాడ్ చేస్తామంటే తీసుకోవడానికి రెడీగా ఉంటాయి. ఎందుకంటే ఆప్టెడ్ కాన్ఫిగరేషన్ వచ్చేసి ఒకటే, అందుకే వాటికి ఎలక్ట్రాన్ గెయిన్ ఎంథాల్పీ వాల్యూస్ వెరీ హై, బికాస్ దే కెన్ అటైన్ స్టేబుల్ నోబెల్ గ్యాస్ కాన్ఫిగరేషన్ బై పికింగ్ అప్ అన్ ఎలక్ట్రాన్. ఒక ఎలక్ట్రాన్ తీసుకోవడం వల్ల వాటికి ఆప్టెడ్ కాన్ఫిగరేషన్ వస్తుంది కాబట్టి, నోబెల్ గ్యాస్ కాన్ఫిగరేషన్ వస్తుంది కాబట్టి. On the other hand, noble gases have large positive electron gain enthalpies because the electron has to enter the next higher principal quantum level, leading to a very unstable electronic configuration. For noble gases ki large positive electron gain enthalpies untai antunnadu. What is the reason behind of that? Already they have stable configuration. While adding of the one more electron, they are becoming unstable or not? Because of that reason, they have a large positive electron gain enthalpies. It may be noted that electron gain enthalpies have a large negative values towards the upper right of the periodic table and preceding the noble gases. Okay, so this is about electron gain enthalpy. Similarly, how the factors influenced the ionization potential. Similarly, factors influencing electron affinity also. Right. So electron affinity, it depends upon the size of the atom, effective nuclear charge of the nucleus, shielding effect similarly, and electronic configuration. The four factors what we have taken in the ionization potentials, those are similar factors. Four factors we are considering here: atomic size, effective nuclear charge, shielding effect, and electronic configuration of the element. So based on these factors also, electron affinity going to be changes. That means varies. How it is changing in groups and periods. In groups, electron affinity decreases from top to bottom as the atomic size is increases. See students, in groups electron affinity decreases antunnadu. Asalu group lo electron add cheyalsina necessity లేదు. Group are having, for example, first group if you have taken extra one electron is there from the octet configuration. So because of that reason, we have, when we will remove the electron, we are getting octet configuration. So because of that reason, those are all the electrons which are present in the first group. They are ready to lose the electrons. But what we are doing here, we are adding the electron. It's not required for those electrons. So because of that reason, what electron, that we are adding the electron. Definitely they will get what? It is decreasing in the values itself. Why? Because atomic size is increases. So in groups, electron affinity decreases from top to bottom as the atomic size is increases. In a period, if we will observe, see, once oxygen required 2 electrons to get the configuration, octet configuration, noble gas configuration. Nitrogen requires 3 electrons. Similarly, halogens required 1 electron. That means they require the electrons. So when electron is added, okay, we are ready to take the electrons. Because of that reason, what? The increasing in the energy we are going to absorb. It's in a period from left to right side, electron affinity increases due to decreasing in atomic size. We can easily add of atoms and increasing in the nuclear charge also. Same shell electrons are present and the nucleus is having more attraction force on the shells because the same shell is present and the nucleus charge is increases. Because of that reason, electron affinity is going to be increases in the periods itself. So finally, the last property is what? Electronegativity. What is electronegativity? Should ionization shell ante valence shell lo ఉన్న electron ని తీసేయడానికి require అయ్యే energy. Electron gain enthalpy in the means what? By gaining of one electron, by adding of one electron to an element, the energy is released by the element. అది తీసేయడానికి కావాల్సిన ఎనర్జీ, ఇది యాడ్ చేయడం వల్ల రిలీజ్ అయ్యే ఎనర్జీ. మరి ఎలక్ట్రోనెగటివిటీ అంటే వాట్ ఈస్ మెంట్ బై ఎలక్ట్రోనెగటివిటీ? సో హియర్ ద ఎలక్ట్రోనెగటివిటీ ఈస్ the qualitative measure of the ability of an atom in chemical compound to attract shared electrons itself is called as electronegativity. So once again, children, see here, a qualitative measure of the ability of an atom in chemical compound to attract shared electrons itself is called electronegativity. So the tendency of an element to attract an electron towards its సో ఒక ఎలక్ట్రాన్ తన వైపుకు ఆకర్షించుకోవడానికి అవసరమైనటువంటి ఎనర్జీ. సో ఎలక్ట్రాన్ తన వైపుకు ఆకర్షించుకోవడం ద్వారా, దట్ మీన్స్ వాట్? బై అట్రాక్టింగ్ ఆఫ్ అన్ ఎలక్ట్రాన్ ద ఎలిమెంట్ ఈస్ గోయింగ్ టు గెట్ ఎ నెగటివ్ చార్జ్ ఆర్ నాట్. సో ద ఎబిలిటీ ఆఫ్ అట్రాక్టింగ్ ఆఫ్ ఎలక్ట్రాన్ ఆఫ్ అన్ ఎలిమెంట్ టువర్డ్స్ ఇట్ సెల్ఫ్, టువర్డ్స్ ఇట్ సైడ్ is called as what? Electronegativity. So by attracting of electron, the element will get which charge? Negative charge. So electronegativity. రుణ విద్యుదాత్మకత అని చెప్తాం మన తెలుగులో. ఎలక్ట్రాన్ ను తన వైపుకు ఆకర్షించుకునేటటువంటి స్వభావాన్ని, దాని యొక్క సాంద్రతను ఏమంటున్నాం? ఎలక్ట్రోనెగటివిటీ లేదా రుణ విద్యుదాత్మకత అని చెప్తున్నాం. సో once you will observe in groups, the necessity is not there to attract the electrons, but whereas in the periods it is required to attract the electrons. Why? Because by gaining of electrons only, by attracting of electrons only, they are getting the stability. So periodic elements are, period elements are ready to take the electrons, ready to attract the electrons, but not the groups. So obviously, I think you understood. In groups what will happen, in periods what will happen, electronegativity. So among the periodic table, if you are going to see here, the highest electronegative element is fluorine and its value will be 4 itself. So it is the most electronegative element in the periodical table here itself. So once we will see the diagram, children, let's go through the diagram. It is all definitely it is present in your academic book also, where the arrow mark is representing towards the arrow here itself. See once here, this is the sharp edge of the arrow. This is the sharp edge of the arrow. These are the arrows. It represents what? It here in every arrow one property has written. Once you see here, electron negativity here itself. What is the meaning of giving of this symbol in different directions he has given? Once you observe first property, we are going to observe here orange color arrow is there, atomic radius is there. So in which manner we need to observe, understand here? Where is the arrow sharp edge is there towards that side, we can understand it is increasing, whatever the property itself. So from here onwards, what property is there? Atomic radius. So from top to bottom, atomic radius in groups from top to bottom is increases. Where the sharp edge is there, that indicates increases. Now once you see electronegativity from bottom to top, here he has given top to bottom. So this is the starting point and this is the increasing point. This is the starting point and this is the increasing point. That means electronegativity from bottom to top, it is increases. Similarly, electron gain enthalpy in a period going to be increases. Ionization enthalpy in period it is increases. Ionization enthalpy from bottom to top he has given, not top to bottom here itself. So reverse, if you have taken what? Top to bottom, it will be. So ionization enthalpy in groups, if you are going to observe, what will happen? From bottom to top, it is going to be enhances. Similarly, electron gain enthalpy from bottom to top increases. Similarly, atomic radius. Actually, what? Atomic radius in periods, what will happen? It will be decreased, but he is given in reverse manner. From right to left, it is going to be increases. Where the sharp edge is there, every property, observe children, where the sharp edge is there, that indicates increasing in the given property. Here electronegativity is there. We know that electronegativity, what will happen from left to right? Going to be increased or not? So because of that reason, if you are going to see here, what? Electronegativity value clearly going to be increases. So every property, once again I am saying clearly, the starting point of the arrow, this one, every property, this is a starting point and the representation of the sharp edge of the arrow indicates increasing. And the direction also you can observe. Some of the children, their understanding is what? So from that here to here the symbol is there. Actually in group electron negativity, what will happen? Electronegativity should be actually, it should be decreases, but it has given in a reverse. What? Bottom to top it is increases. So top to bottom what will happen? Decreases. So these are the periodic properties generally in the periodic classification. We have discussed different type of periodic tables. After that, depends on what factors, and the factors are what? How they are varying in groups and periods. Electronegativity, it is the property of isolated atom. It is the property of bonded atom. The tendency of an atom to attract the shared electron pair towards itself in a molecule is called as electronegativity. ఎలక్ట్రాన్ జంటను తన వైపు ఆకర్షించుకునేటటువంటి ప్రవృత్తిని ఒక మూలకం యొక్క రుణ విద్యుదాత్మకతగా చెప్తున్నాం మనం ఇక్కడ. So electronegativity is a relative property and has no units. Already we have seen ionization potential units in a kilojoule per mole, and we are saying the units in angstroms or picometers for atomic radius. But electronegativity is a relative property. దీనికి యూనిట్స్ అనేటటువంటివి లేవు. And what are the factors influencing electronegativity? Atomic radius, and electronegativity is indirectly proportional to atomic radius. By means what? If atomic radius increases, electronegativity values are decreases. If atomic radius is going to be decreases, electronegativity values are going to be increases. This is the first factor. Similarly, effective nuclear charge and electron oxidation state, both are directly proportional to electronegativity itself. By means what? Effective nuclear charge gani oxidation state both are increasing means electronegativity values also going to be increases. So this is about electronegativity. And next one, acidic, basic, amphoteric nature of oxides. So nature of oxides also we have in this lesson. So what are they? Based on the nature of oxides are classified into 4 types. One is basic oxides or metal oxides, acidic oxides or non-metal oxides, third is amphoteric oxides, the fourth is neutral oxides itself. So what are basic oxides, what are neutral oxides, what are amphoteric oxides? We will see. Basic oxides are nothing but, first if you will see in the periodic table, first group are alkali metals and second groups are alkaline earth metals here itself, that we know very well. So metal oxides are generally basic oxides. Metal oxides are generally basic oxides. See once, generally metals form basic oxides, that is Na2O, sodium is a metal, soft metal. Barium oxide, magnesium oxide, calcium oxides. As the metallic nature increases, basic nature of oxides increases. We have discussed metallic property, non-metallic property, group, period, how they have variated. So where metallic nature increases in the groups are not, losing of electrons is called as, and getting a positive charge is called as metallic nature. that is increasing in the group. So because of that reason, as the metallic nature increases, basic nature of oxide is increases. First A, second A group metal oxides are strong bases. Generally, non-metals are formed acidic oxides. See, acidic oxides are non-metal oxides. Non-metal oxides are what? That is, they won't get a positive charge, but sodium will get a positive charge, form cation. Those will form cation. But these sulfur, phosphorus, carbon, phosphorus, nitrogen, these cannot form a positively charged cations. So these are non-metals. They will gain the electrons and getting a negative charge. See, sulfur dioxide, phosphorus pentoxide, carbon dioxide, phosphorus trioxide, nitrogen dioxide. These are all what? Non-metallic oxides. These non-metallic oxides are acidic oxides, but metallic oxides are basic oxides. So after that, completion of basic oxides and acidic oxides. Metallic oxides are non-metallic oxides. Then we are going to discuss about amphoteric oxides. So what are amphoteric oxides? As the non-metal nature increases, basic nature of oxides increases. That's we know that. Oxides of halogens are highly acidic metalloids from amphoteric oxides. So what are amphoteric? Those the elements which can have the metallic nature as well as the non-metallic nature, those can be called as metalloids. The metalloids which are forming the oxides like As2O3, Sb2O3, TuO2, GuO2. These are all what? Amphoteric. They are having both natures, acidic nature as well as basic nature. So in this chapter, majorly we have discussed what? Nature of the oxides and electronegativity, and denation potentials. After that, metallic, non-metallic property. After that, atomic size, atomic radius, different type of atomic radius, valence electrons, and electronic configuration. How can we write? So different type of periodic tables, what properties, what principle they have, and the classifications. These are all completely we have discussed. So children, majorly we need to concentrate on the especially ionization potentials and its factors in this lesson, especially blocks regarding the SPDF blocks here itself. After that, you need to concentrate on SPDF blocks and periodic tables as well as periodic properties itself. Okay, so children, physical properties. Okay. So these are the nature of and acidic, basic, and amphoteric nature of oxides. Neutral oxides also present, like a carbon monoxide. It is a neutral oxide. It does not have the acidic nature and the basic nature here itself. Okay. So acidic nature, basic nature, amphoteric nature of oxides. And once you observe here, basic nature oxides. Example, if you have taken sodium oxide is there. These basic nature oxides, if you are going to treat it with the water, that means these basic oxides are dissolved in water, like sodium oxide, barium oxide, magnesium oxide, calcium oxide. When these are going to dissolve in water, at that time, they are going to form bases, like what? Na2O plus H2O. And sodium oxide is going to treat it with water. That means we are dissolving the sodium oxide into water here itself. When it is dissolved in water, what will happen? It is forming sodium hydroxide. Sodium hydroxide itself. So because of that reason, and hydrogen gas is released. Similarly, barium oxide is also dissolved in water. By means what? What are the basic oxides, metal oxides? When we are going to dissolve in water, they are going to form a basis itself. Similarly, if we will take the non-metal oxides or acidic oxides, like what? Sulfur dioxide, phosphorus pentoxide, carbon dioxide. These are the acids. If dissolved in water, at that time, they are going to form the acids. If sulfur dioxide, carbon dioxide, these are going to dissolve in water, they are going to form sulfuric acid and a carbonic acid, like what? Phosphoric acid, nitric acid. These are going to be formed. That means nothing but what? when basic oxides are going to dissolve in the water, they are going to form bases. Then acidic oxides are going to dissolve in water, they are going to form acids. Okay, so these are the this is the general phenomenon of acidic and basic nature of the oxides generally. After that, we met some amphoteric oxides also we have discussed, and neutral oxides. The neutral oxides, for example, if we have taken, that's what carbon monoxide TSL. And after that, that is a carbon monoxide which does not have the acidic nature and as well as the basic nature here itself. So the final one is what? Anomalous behavior of some properties we are going to observe in the periodic table. Let's see, children, ionization potential if we have taken. Actually, ionization potential if you observe in the periods, what it should be happen? It should be increases. Ionization potential generally in it should be increase in the period. Once you observe here, in periods from left to right, ionization potential increases due to decreasing in atomic size. But we observe, if we'll observe in the elements like nitrogen and phosphorus, oxygen and nitrogen. Once you see here, oxygen and nitrogen. Once you observe here, from lithium to neon, ionization potential values as per the instruction what we have based on the atomic size, it should be increased. By means what? Beryllium has more ionization potential than lithium, boron than beryllium, carbon than boron, nitrogen than carbon, oxygen than nitrogen. But here a small difference we are going to observe here itself. So what is the reason behind of this? Sir.
Sir, kindly close the session, sir.
Yeah, okay, sir. So okay, children, that is the anomalous behavior we are going to observe, nitrogen and oxygen. If you will see here, nitrogen is having the configuration of, here if we will see 1s2 and 2s2 2p3, that is 5 electrons which is present in nitrogen. In oxygen, 1s2 2s2 2p6, 2s2 2p4 will be. That means 6 electrons in present in the second shell. Here once you observe, 2s2 2p3 is 5 electrons, 2s2 2p4 is 6 electrons. This is showing half-filled configuration in P subshell in the second shell. Complete fulfilled configuration is S subshell. S lo 2 electrons will happen, P lo 3 electrons will happen. But here S 2 electrons in second shell, P 4 electrons in the second shell. It means what? It is having half-filled configuration in the second shell. Because of that reason, the nucleus positive charge is going to attract this shell towards more to the nitrogen nucleus. But whereas nitrogen is not. By means oxygen kante kuda nitrogen shell lo undetvanti electrons ekkuva kendra ganiki daggaraga lagabadtayi. Because of that reason, in order to remove an electron in the nitrogen, more energy is required than the oxygen. So this is a slight difference we are going to observe. Actually lithium nunchi neon varaku increase avvali. Ante carbon kante nitrogen ekku undali untundi. Kan nitrogen kante oxygen ekku undali, ala undadu. Oxygen is less ionization potential, having less ionization potential, and nitrogen is having more ionization potential. That is a different trend that we are going to observe only in the nitrogen and the oxygen group here itself. So similarly, that we are going to observe in atomic radius. Okay, atomic radius also, when shells are pulled towards the nucleus, what will happen? Atomic size also, atomic radius also is going to be decreased or not. So because of that reason, atomic radius, ionization potential, these two properties are going to be have slight variation, not for the genuine manner, not as the genuine manner. Increase avvalsindi, decrease avvalsindi, ikkada increase avutadi, increase avvalsindi, ikkada decrease avutundi. So these are the anomalous behavior we are going to observe, the atomic size and as well as ionization potential values itself. So based on these, the remaining properties also will be affected. Okay, so this is about what? Periodic classification lesson. So thank you, children, and thank you for giving the opportunity to.
Okay.
Sir.
Thank you.
Okay, sir.
Okay. Yeah. Yeah. కానీ ఆన్లైన్ లో చూస్తుంది ఆన్లైన్ ఫోటో తీసుకోండి ఆన్లైన్ రాదు ఇంకా ఆన్ కాలే కెమెరా లేదా అట్లే కదా చూసిందా చూసుకోండి చూసుకొని పని చెందు రాడా అమ్మాయి చెందు రాడా भैया मैसेज लगाओ नेक्स्ट क्लास का नेक्स्ट करके आगे भाई बेटा आओ मैडम जाओ रिपोर्ट नहीं पहुंचता Good morning, ma'am.
గుడ్ మార్నింగ్.
గుడ్ మార్నింగ్.
ఎవరు? కాశీనాథ్.
ఎస్ మేడం.
ఓకే ఓకే ఓకే. నాకు హోస్ట్ ఇస్తావమ్మా?
ఇస్తున్నా.
ఇస్తే నేను మేడంకి హోస్ట్ ఇస్తాను, లేదంటే మీరు ఇచ్చినా పర్వాలా.
క్లాస్ మీరే తీసుకుంటారు?
జనరల్ గా జువాలజీ క్లాస్ నేను హోస్ట్ తీసుకుంటాను, నేనే ఎండ్ చేస్తాను. మీరు అటు ఇటు పోయినా కొంచెం నేను వెంటనే ఎండ్ చేసేస్తాను. అది
లేదు నేను ఉంటాను మేడం, ఉంటాను.
అంటే జనరల్ గా అయితే ఇస్తారు, నేనే ఎండ్ చేస్తాను అట్లా.
ఓకే మేడం.
ఓకే మేడం ఇంకా జాయిన్ అవ్వలేదు, ఫోన్ చేస్తాను ఒకసారి.
ఓకే మేడం.
దీంతో ఈరోజు దేశం మొత్తం యుద్ధం చేస్తోంది, దాన్ని గుర్తుంచుకోండి.
అదే అట్లా పక్కన చక్కగా వెళ్ళిపోతుంది కొంచెం. స్క్రీన్ షేర్ చేయలేదు, వీడియో కూడా ఆన్ చేయలేదు. మనం చేద్దాం.
మేడం శారదా మేడం.
మేడం మేడం వస్తుంది. కొంచెం
ఓకే, మీకు పోస్ట్ ఇచ్చాను. ఇంకా టైం ఉంది మనకు కొంచెం. 11:45 కదా,
ఇంకా 5 minutes.
5 minutes more. ఓకే, చెప్పేటప్పుడు ఇది చెప్తావు కదమ్మా, మ్యాట్రిక్స్, సెల్ మ్యాట్రిక్స్ గురించి.
సెల్ మ్యాట్రిక్స్ కాదు మేడం, ఈరోజు వచ్చి యానిమల్ టిష్యూ.
అదే యానిమల్ టిష్యూస్ లో ఎక్స్ట్రా సెల్యులార్ మ్యాట్రిక్స్ గురించి నేను అనేది. సెల్స్ అండ్ ఎక్స్ట్రా సెల్యులార్ మ్యాట్రిక్స్ బోత్ ఆఫ్ దెమ్ టుగెదర్ ఫార్మ్ ద టిష్యూస్ కదా. అదే స్లైడ్ నాకు ఎక్కడ కనపడలేదు, చెప్పేటప్పుడు చెప్దాం అనుకున్నావా అంటున్నా.
చెప్తాను మేడం, పాయింట్స్ లో కవర్ చేస్తాను.
అంటే టిష్యూ ఎట్లా ఫామ్ అవుతుంది అనేది ఫస్ట్
మేడం, ఫస్ట్ ఇంట్రొడక్షన్ అదే వచ్చింది. యానిమల్ టిష్యూస్ లో ఫస్ట్ అదే ఇచ్చాను. అది
అదే కదా ఇప్పుడు చెప్పేది యానిమల్ టిష్యూసే కదా.
అవును మేడం, యానిమల్ టిష్యూసే టాపిక్.
ఓకే, అదే అంటే మళ్ళీ ఒకసారి రీక్యాప్చులేషన్ లా ఉంటది. అంటే స్టార్టింగ్ టిష్యూస్ స్టార్టింగ్ కదా.
ఓకే 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 మేడం.
అంతేలే. ఇంకా ఒకటి సిమెంటింగ్ సబ్స్టెన్సెస్ మేడప్ ఆఫ్ కార్బోహైడ్రేట్స్ గుర్తుంటే అది చెప్పేసాయి.
చూస్తా మేడం, సీక్వెన్స్ లో ఇక వాటిని బట్టి యాడ్ అవుతా ఉంటాయి.
అదేలే, మీరు ఏదో అనుకొని ఉంటారు, వస్తే కనుక అదే ఆ మాట. అంటే అది ఎక్స్ట్రా పాయింట్ అన్నట్లు కొంచెం.
మొన్న మీరు ఉంటే అయిపోయేది ఆ రోజు
సాటర్డే రోజా? ఆ రోజు నేను యాక్చువల్గా ఉన్నాను అక్కడ, కానీ అమ్మాయికి రావట్లేదు సరిగా. నెట్ ఒకటి డౌన్ అయింది, ఆ అమ్మాయికి ఏమో రావట్లేదు, మధునేమో హాస్పిటల్కి వెళ్ళాడు. అట్లా దాంతో పాపం అసలు చాలా ఇబ్బంది అయింది. అసలు నేను చూసినా బాగుండేది మధు చేసేటప్పుడు, ఒక్కసారి అయిపోయేది. స్టార్ట్ చేద్దామా? ఎంత అయింది? 11:42.
అవుతుంది మేడం. స్టార్ట్ చేద్దామంటే మేము
అలవాటు పడ్డారులే, ఇంకా టెన్షన్ ఫీల్ అవ్వాల్సిన పని లేదు.
అంటే వాయిస్ కొంచెం అంటారు
వాటర్ తాగాలి, మధ్య మధ్యలో కూడా తాగాలి.
అంటే కొంచెం వాటర్ ఉంటేనే బాగుంటది కదా అని.
అవును, మధ్యలో కూడా తాగాలి అసలు యాక్చువల్గా.
మధ్యలో ఒకసారి మధ్యలో తాగుతున్నాను మేడం. ఇంకా అయినా ఇంకా 2 days కదా మేడం.
అంతేనా? మీకు ఇంకోటి వస్తుందేమో చూడండి.
అమ్మో అమ్మో వల్ల కాదు మేడం. రికార్డ్ చేసి పెట్టమనంటే అది వేరే విషయం, కానీ వితౌట్ రికార్డ్ టైమింగ్స్ బాగుంది కావాలంటే కొంచెం కష్టమైతుంది మేడం.
అవును, చాలా అస్సలు చాలా టఫ్ టాస్క్ ఇది. వితౌట్ ఎడిటింగ్ డైరెక్ట్ 45 minutes. ఓకే, స్టార్ట్ చేద్దామా? బాబు కాశీనాథ్,
ఒక్క నిమిషం మేడం.
ఒక్క నిమిషం అట్ట బాబు ఉండు. శారదా రెడీయా?
రెడీ మేడం. ఫస్ట్ ఇంట్రొడక్షన్ నేను ఇది వీడియో ఇది అయిపోయిన తర్వాత స్క్రీన్ షేర్ చేస్తాను మేడం, మొన్నట్లాగా.
అయితే పక్కనే ఉంది కదా, టైం తీసుకోకుండా అవుతుంది కదా స్క్రీన్ షేర్?
పక్కనే ఉంది మేడం. నేను అంటే జస్ట్ అంటే కొంచెం డిస్టెన్స్ లో ఉంటే క్లారిటీ ఉంటుంది వీడియో అని చెప్పేసి.
ఓకే
ఓకే మేడం.
శారదా రెడీ?
షల్ ఐ స్టార్ట్ మేడం?
Yes, you can start.
Okay. Good morning all. This is Sharada, PGT in Bioscience, TSRJC Girls Kodakanla. Welcome you all to my online class. The second chapter of first year geology, that is the structural organization in animals. Already we have discussed the level of organization in animals and silo and symmetry topics. Today we are going to discuss about types of animal tissues. Okay, let's start our class.
Okay, our topic is types of animal tissues. So here we are observing some tissues on the screen. First of all, tissue. Actually, what is the meaning of it? In metazoans, a group of cells and products that are arise from the same region of the embryo, which perform the same function, constitute the tissue. Means a group of cells which are originate from the same place and having the same function are known as the tissue. The study of tissue is known as the histology or microanatomy. So here in this picture, we are observing the different types of tissues like smooth muscle tissue and loose connective tissue, nervous tissue, blood, and columnar epithelium. So all these are the different types of tissues. So let us go for the detail. In animals, mainly there are 4 types of tissue are there. The first one is the epithelial tissue, second one is the connective tissue, third one is the muscular tissue, and fourth one is the nervous tissue. First, epithelial. Epi means upon. The tissue which covers outer body surface and lining the internal organs is known as the epithelial tissue. Once again, I repeat, epithelial tissue means the tissue which covers the outer body surface and lining the internal organs. So regarding epithelial tissue, here we are observing the intercellular junctions of epithelial tissue. Means they are present at the place of epithelial regions only, but we are giving different names according to their structure and function. Okay. The first one is the tight junction, and second one is the desmosomes, and third one is the gap junctions. Okay. Intercellular. Inter means between two cells place is known as the inter. Within the cell is known as the intra. There is a lot of difference between the intra and inter. Intra means within the cell. Inter means between the two cells. So the epithelial tissue which is present and having different functions, according to that we are grouping them as the tight junctions and desmosomes and gap junctions. First, let me explain you tight junctions. So here in this picture, you are able to see the tight junction. Okay, here cell A and cell B. This is the cell B and this is the cell A. So here you are able to see the tight junction, which is a bonding, which is having a thick connection. Okay, the tight junction. Okay, here they prevent the leakage of water in surroundings, into the surroundings. Okay, so here when we go for the definition, the tight junctions which are present at the epithelial regions, they prevent the leakage of water into the surroundings. Examples, sweat glands. Usually the epithelial tissue tight junction which are present at the place of sweat glands, they prevent the leakage of water into the surrounding. So with the help of tight junction, the water which is present within the cells may not come out. So with the help of the tight junction, it will be controlled. So this is about the tight junction. Now go for the next type of junction. Now, coming to know about the desmosomes. Desmosomes are the specialized protein complexes responsible for maintaining the mechanical integrity of tissues. So here in this picture, we are able to see the protein filaments which are made up of with the keratin. What is the name of the protein? It is the keratin protein, and which is useful for binding with adjacent cells. The filaments which are arise from a particular cell portion which are made up of with keratin will be useful for binding with the adjacent cells. They are known as the desmosomes. Especially desmosomes are present in the muscles. Okay, this is about the desmosomes. Once again, desmosomes are the specialized protein complexes. They are responsible for maintaining the mechanical integrity of tissues. Keratin is a protein and intermediate filament which is useful for binding with the adjacent cell. So here the filaments which are arising from that particular cell region are made up of with the keratin, and they will be useful for binding with the adjacent cells. So this is about the desmosomes. Gap junction. The third type is the gap junction. Here they provide cytoplasmic channels. So in this picture, you are able to see clearly cytoplasmic channels. Here, this is the cytoplasmic channel, means the pathway from one cell to the another cell is known as a channel. That is the cytoplasmic channel. And these are compared with the plasma-desmata of plant cells. So usually in case of plants, the plasma-desmata are the parts which are able to supply the particles from one cell part to the another cell. Just like here also, the gap junctions, which are cytoplasmic channels between the two adjacent cells, are useful for the various types of transfer of various types of ions, just like sugar molecules and amino acids, and pass from a cell to an adjacent cell. So this is about the gap junction. So these are the locations of the gap junctions which are present at the adjacent cell places. With these channels, there is a chance of exchange of materials like the ions, sugar molecules, amino acids will be passed from one cell to the another cell. This is about the gap junctions. Okay. Now go for the next topic. Now, the types of epithelial tissues. Epithelial tissues are again divided into two types. One is the simple epithelium and second one is the compound epithelium. Now, here in this flow chart, we are able to see the simple epithelium is again divided into squamous epithelium, cuboidal epithelium, and columnar epithelium. Okay, and another type is the compound. So first go for the simple only. Okay, epithelial tissue is divided into two types. Number one is the simple epithelium and number two is the compound epithelium. So when we go for the simple epithelium, it is again divided into three types: squamous, simple squamous epithelium, and cuboidal and columnar. So first we go for the only simple epithelium only. Okay. Simple epithelium. The term itself indicating that it is very simple, very transparent. Okay. If it is having only one layer, that is the simple epithelium. Simple epithelium composed of a single layer of cells and form the lining of body cavities, ducts, and vessels. And it helps in the diffusion, absorption, filtration, and secretion of substances. Okay, so due to its structure, which is having only one layer, that is the reason it is useful for in the diffusion process and absorption process and filtration and secretion of substances. So here in this picture, you are able to see simple squamous epithelium. Means simple means it is also having only one layer. Simple squamous. Why we are mentioning the squamous means it is having the flat structure. Okay. Let us go for the points. Simple squamous epithelium, it is composed of a single layer of flat structure. So it is just look like a flat-like structure. And each cell with centrally located ovoid nucleus, the round nucleus which is centrally present. It is found in the endothelium of blood vessels. What do you mean by endothelium? The inner side. Ecto means outer side. The blood vessels which are having the inner side of the blood vessels are having the simple squamous epithelium. And mesothelium of body cavities, just like pleura and peritoneum. And wall of Bowman's capsule. Bowman's capsule, it is a part of nephron. and lining of alveoli of lungs. The alveoli, which are very, very important for the exchange of gases. So there also we are observing the simple squamous epithelium. It is very transparent and a single layer and very flat in structure. So that is the reason it is especially present in the endothelium of the blood vessels and Bowman's capsule of nephron and lining of alveoli of lungs. So here you are able to see the nucleus is round in structure, okay, and having the flat structure. All these are the points of a simple squamous epithelium. Now go for the next one. Here also simple but cuboidal. Simple means having only one layer. Cuboidal means it is having the shape of cube shape. That is the epithelium. Now, in this regard, it is composed of a single layer of cube cells and with centrally located spherical nucleus. How the nucleus is appearing like here, when we are observing or when we are focusing only on the nucleus, it is with spherical, and it is found in the germinal epithelium and PCT and DCT of nephron. Actually, a nephron is consisting with the Bowman's capsule and PCT, loop of Henry, and DCT and collecting tubules. Especially in PCT and DCT of nephron, it is having the simple cuboidal epithelium, means the cells are having the cube shape cells and which are useful for the absorption or exchange of materials. Okay, so this is about the simple cuboidal epithelium. This is the cube shape and this is the nucleus with a spherical shape and having only one layer. Simple cuboidal epithelium. Okay, now go for the next one. Simple columnar epithelium. The term itself, columnar, means it is having just like slender shape. It is composed of a single layer. Simple means always you should remember that it is only having one layer. And columnar means just like the slender shape and with the oval nuclei located near the base. Nucleus is present, but at the base place you are able to see it. So here you are able to see the nucleus which is exactly at the place of a base region. Okay, this is about the simple columnar epithelium. Again, it is divided into two types: ciliated columnar and non-ciliated columnar. Okay, ciliated columnar and non-ciliated columnar. So this is about the columnar which is having slender shape and the nucleus is at the place of base region. And again it is divided into two types, that is the ciliated columnar and non-ciliated columnar. Now go for the next one. Here, ciliated columnar epithelium means a columnar epithelium, but it is having cilia on the surface. That is the definition for it. Okay. Now go for the detail. Here, these are the cilia-like structures which are present on the surface of the cells. The cells are slender shape and they are also having the nucleus at the base, but they are having the cilia-like structures on the surface. So where we are observing such type of ciliated columnar epithelium means it is present inner surface of organs like fallopian tubes, ventricles of brain, central canal of spinal cord, and branchioles. So all these are the regions we observe the ciliated columnar epithelium. What are the regions? Surface of the organs like fallopian tubes, ventricles of brain, central canal of spinal cord, and branchioles. So this is about the ciliated columnar epithelium. Okay. Now here, non-ciliated columnar epithelium. Here also you are able to see the cell with columnar shape, but cilia are not present. Instead of cilia, you are able to see here microvilli. Columnar cells are without cilia. It is found in the lining of stomach and intestine. The microvilli are present in the columnar epithelium of intestine to increase the surface area of absorption. What is the main function of the microvilli? It increases the surface area of absorption in stomach and intestine. This is about the non-ciliated columnar epithelium, which is not having the cilia, but instead of cilia, it is having microvilli, which are useful for the increase the surface area of absorption. Okay, so this is the cell, and these are the microvilli. Okay, now go for the next one. Here, already we discussed just now only. Here, the epithelium is divided into two types. One is the simple, means which is having only single layer, and another type is the compound, means which is having more than one layer. Okay, here we go through this picture. So it is made up of more than one layer of cells. That is known as the compound epithelium or stratified epithelium. Here, it is again divided into two types: stratified keratinized squamous epithelium and stratified non-keratinized squamous epithelium. Means both are squamous epithelium of stratified only. But if the keratin is present, that is the stratified keratinized. If the keratin is absent, that is the non-keratinized. So here in this picture, you are able to see the layers, more than one layer. The cells are arranged in more than one layer. That is the reason it is called as the compound epithelium or stratified epithelium. Okay, so this is about the compound epithelium or stratified epithelium. The cells which are arranged in more than one layer. Okay, now go for the next slide. Stratified keratinized squamous epithelium. So just now only I explained. Here it is the stratified, means having more than one layer, but it is covered with the keratin. Example is the surface of the skin, which is having the keratin. Okay, and non-stratified, non-keratinized. Okay, here non-keratinized means it is not having the keratin layer, but stratified means having more than one layer. Usually it is observed in a moist surfaces like buccal cavity or pharynx and esophagus regions. The moist surfaces like where we are able to see such type of means buccal cavity and pharynx and esophagus. Okay, this is about stratified keratinized squamous epithelium and stratified non-keratinized squamous epithelium. So this is the picture. This one is the keratin layer. In this picture, it is not having the keratin layer. So this is the difference between the stratified keratinized and non-stratified keratinized. Okay. Comparison. Stratified squamous epithelium, non-keratinized and keratinized. Just simply we can say if a keratin is present, that is a keratinized. If a keratin is absent, that is the non-keratinized. Okay, so this is the comparison picture of a stratified squamous epithelium of a non-keratinized and keratinized. Highly keratinized. Here you are able to see the highly keratinized. Here you are not able to see the keratin layer. Okay, so this is the difference of the two types of squamous epitheliums. Now the next one is the glandular epithelium. The term itself indicating gland means secretion. A gland means a portion which is able to secrete something is known as a glandular epithelium. Here in this picture, so you are able to see a duct-like portion. Some of the columnar or cuboidal cells that get specialized for the production of certain secretions from glandular epithelium. So again, there are two types, unicellular and multicellular. If it is having only one cell, that is a unicellular. If it is having more cell like clusters, that is a multicellular glands. Okay, nothing here. Glandular means some of the columnar or cuboidal cells that get specialized for production of certain secretions from the glandular epithelium are known as a glandular epithelium. If it is made up of with a single cell, unicellular. If it is made up of with multi-cells, multicellular glands. Here, unicellular and multicellular. So unicellular means only single cell is consisting of isolated glandular cells such as goblet cells of the gut. Okay. Multicellular glands consisting of clusters of cells such as salivary glands. So in this picture also you are able to see the difference of uni and multi. Unicellular and multicellular glands. This is the difference between the unicellular gland and multicellular gland. Now, on the basis of mode of releasing of the secretions, glands are divided into two types, namely exocrine, endocrine. Number of times we heard these two words, exocrine, endocrine. Let me explain first about the exocrine glands. Exocrine glands are provided with the ducts, secrete mucus, saliva, earwax, oil, milk, digestive enzymes. All these are the secretions which are secreted by the exocrine glands. Okay. Now come to know about the endocrine glands. So endocrine glands are ductless. Especially we should mention the ductless, and their products are hormones which are not sent out via ducts, but they are carried to the target organs by blood. How they will be reached to the target organs means with the help of the blood. So this is about the exocrine and endocrine. The exocrine products are mucus, saliva, earwax, oil, milk, digestive enzymes. And endocrine gland secretions are called as the hormones, which are not sent out via ducts, but they are carried to the target organs by blood. Okay, this is the difference between the exocrine and endocrine glands. Endocrinology, the study of hormones. Okay. Now, based on the mode of secretion of exocrine glands are three types: merocrine, apocrine, and holocrine. So based on the secretion, how they are secreting outside. So based on that, we are grouping them into three types. What are they? Merocrine, apocrine, and holocrine. So let me explain one by one. Okay. Here, the first one is the merocrine. Pancreas is the example. So here, which release the secretory granules without loss of other cellular material. Only the secretion only comes out from that cell, from that cell. The such type of secretion method is known as a merocrine. Pancreas is the example, which release the secretory granules without loss of other cellular material. So in this picture also you are able to see that. Apocrine, the term itself, apho means apical, means top. Example, mammary glands, in which the apical part of the cell is pinched off along with the secretory product. So in this picture, you are clearly able to see that the apical part only pinched out along with the secretory product. Example, mammary glands. But the third, hollow means complete. Here, example, sebaceous glands, in which the entire cell disintegrates to discharge the material or secretory product. The entire cell is disintegrate here. So that is the holocrine method. Merocrine means without loss of cellular material. Apo means apical part will be somewhat deviated from that particular cell portion. Hollow means the complete cell. Okay. So these are the three types of methods according to their secretion secretory method. We are giving different names, and that is these are the pictures to identify them in a clear manner. First one is the mero, and this is the apo, and this is the hole. So these are the three types of methods. Now, so that is about all about the epithelial tissue. Okay. Now let us come to know about the connective tissue. So regarding animal tissue, epithelial tissue, connective tissue, and nervous tissue. Okay. So let me explain about the connective tissue now. Connective tissue, the term itself indicating connection, means the connective tissue are the most abundant and widely distributed tissue in the body of higher animals. They are named connective tissue because of their special function of binding and supporting other tissues or organs in the body. They are mesodermal in origin. Connective tissue consists of cells and large extracellular matrix. It contains different combinations of fibers and ground substances, which include water, polysaccharides, and proteins. So let me explain detail about all these points. Extracellular matrix and ground substances and fibers and cells. Okay. Now let us go for this flow chart. So the structure of the connective tissue is having three components like cells and fibers and ground substances. So here the fibers and ground substances comes under the extracellular matrix. Okay. So these are the cells and these are the extracellular matrix particles like fibers and ground substances. So regarding cells, fibroblast, macrophages, mast cells, plasma cells, lymphocytes, leukocytes, adipose cells. So all these are the types of cells which are present in the connective tissue. Okay. Fibers means, for example, if it is the cell, the fibers and the ground substances comes under the extracellular fluid, which are present. Extra means the outer portion. Fibers and ground substances. When we come to know about the fibers, they are reticular, elastic, and collagen type of fibers. And ground substances, glycoproteins and macromolecules are the ground substances. So by all these, the connective tissues are made up of. The main components of the connective tissue are cells, fibers, and ground substances. Cells are different types like macrophages, mast cells, plasma cells. Fibers, reticular, elastic, collagen, and ground substances like glycoproteins. So all these are the materials which are made up of, which are useful for the making the connective tissue. Okay. Now go for the next slide. Connective tissue again divided into three types: connective tissue proper, skeletal tissue, and fluid connective tissue. Okay. So here the connective tissue is again divided into three types: connective tissue proper, and skeletal tissue, and fluid connective tissue. First, go for the connective tissue proper. The connective tissue proper is again divided into two types: loose connective tissue and dense connective tissue. In loose connective tissue, again it is divided into three types. One is the areolar, adipose, and reticular. And dense connective tissue is also divided into three types, that is the regular, irregular, and elastic. This is the classification of the proper connective tissue. Okay. And skeletal tissue means here skeleton means bones, spongy and compact. And the third one is the fluid connective tissue, the blood. So here coming to the skeletal, bone and cartilage both are comes under the skeletal, but fluid connective tissue means the blood. Blood is the fluid connective tissue. So all these will be comes under this connective tissue topic. So let me explain one by one. So this is the classification of the connective tissue, and here we are grouping the connective tissue into three types. That is, the first one is the connective tissue proper, and second one is the skeletal tissue, and third one is the fluid connective tissue, that is the blood. First, in connective tissue proper, again it is divided into loose connective tissue, dense connective tissue. In loose, again it is having three types: areolar, adipose, reticular. In dense connective tissue, regular, irregular, elastic. Coming to the skeletal, bone and cartilage, sponge and compact, cartilage, elastic, hyaline, and fibrocartilage. These are the types of cartilage. And complete fluid connective tissue is the blood. So all will be discussed in the connective tissue, and this is the classification of the connective tissue. Okay. Now, first we go for the only connective tissue proper. Okay. Connective tissue proper again divided into two types. The first one is the loose connective tissue, and second one is the dense connective tissue. In loose connective tissue, few fibers and more ground substances will be present. In dense connective tissue, more fibers, less ground substance is present. In loose connective tissue, areolar, adipose, and reticular. And in case of dense connective tissue, reticular and regular, irregular, and elastic. These are the types. Okay. In case of connective tissue proper, again it is divided into two types. One is the loose connective tissue, second one is the dense connective tissue. When we come to know about the loose connective tissue, loose means the term itself indicating few fibers and more ground substances is present. Examples: areolar and adipose and reticular. And dense connective tissue, regular, irregular, and elastic. Okay, this is the classification of the connective tissue proper. Now, loose connective tissue, just now only we classified it as areolar tissue, adipose tissue, and reticular tissue. Let me explain first areolar tissue. So this is the picture of areolar tissue. It is one of the most widely distributed connective tissue in the body, from the packing tissue in almost all the organs. Means it is having a link with all the organs. Areolar, it is just like a packing tissue, which is able to having link with all the organs in the body. The cells of the areolar tissue are fibroblasts, mast cells, macrophages, adipocytes, and plasma cells. Okay, let me explain them. So here the cells of the areolar tissue are fibroblasts. Most common cells which secrete fibers. Fibroblast means they are able to secrete the fibers. mast cells. So here the mast cells secrete heparin. Heparin means an anticoagulant. And histamine, bradykinin, vasodilator, and serotonin, vasoconstrictor. So here the two terms, vasodilator and vasoconstrictor. Vaso means vessel, blood vessel. Dilator means it expands the blood vessel. And constrictor means it decrease the diameter of the blood vessel. Okay. And vasodilator cause inflammation in response to injury of an infection. So especially mast cells secrete heparin. Heparin means it is an anticoagulant. Histamine, bradykinin, vasodilator, and serotonin is a vasoconstrictor. And all these will be useful in inflammations and respond to injury and infection. Macrophages. Macro, the term itself is indicating, are amoeboid cells, phagocytic in function, act on as internal scavengers. They are derived from the monocytes. Mast cells, monocytes of the bloods. So they are having the phagocytic function, means they destroy the disease causing agents. And tissue fixed macrophages are called as the histocytes. Okay, the macrophages which are attached with the tissue are called as the histocytes. This is about the macrophages. Fourth one is the plasma cells. They are derived from the B lymphocytes. So B lymphocytes, the main function of the B lymphocytes is the production of the antibodies. For antigens, the antibody production will be going to take place. Adipocytes, number of times we heard adipose is the tissue which is used for the storage of fat. So all these are the cells of the areolar tissue. Okay. Fibroblast means producing the fiber. Mast cells secreting heparin. Macrophages especially for phagocytic in nature. Plasma cells for production of the antibodies. And adipocytes for storage of fat. All these are the types of the cells which are present in the areolar tissue. Now, fibers of areolar tissue are collagen, elastin, and reticular. These are the fibers which are present in the areolar tissue. Now let us go for the adipose. Already we just now only we came to know that adipose is the tissue. So especially it is useful for the storage of fat. Okay. And it consists of large number of adipocytes and few fibers. Cells are more in number, but fibers are less in number. Tissue which is present beneath the skin provides thermal insulation. It is very, very important. The blubber of aquatic mammals such as whales and sea cow, it acts as a, so especially the thermal insulation means the aquatic mammals where they are present at the complete frozen areas, the blubber is giving protection from the certain cool conditions. And it acts as a storage tissue in the hump of a camel. So it is also used as the storage tissue in case of hump of camel. So this is about the adipose tissue. So when we come to know these are the cells and less fibers, and it is especially specialized for the storage of the fat. That is about the adipose tissue. Okay. Now, the adipose is again divided into two types, white adipose tissue and brown adipose tissue. Okay. Now, first we go for the white adipose tissue. It is found in adults, and adipocytes has a single large lipid droplet that is known as monolacular, and white fat is metabolically less active. Okay. White adipose and brown adipose. White adipose, it is found in adults, and the adipose has a single large lipid droplet that is known as monolacular, and white fat is very less active compared to the brown. Now go for the brown. It is found in fetuses and infants. Adipocytes of brown adipose tissue has several small lipid droplets or multicellular and numerous mitochondria. Due to the presence of mitochondria, it is very active. Brown fat is metabolically active and generate heat to maintain the body temperature. Okay, so it is a brown adipose is found in infants and white adipose is found in adults. So go for the picture once again. So this is the brown fat and that is the white fat. Brown fat is very active and white fat is less active. White fat is present in adults and brown fat is present in infants. Okay, this is the comparison between the white and brown fats. Reticular tissue. So, in case of reticular tissue, reticular cells secrete reticular fibers. Reticular fibers. They form an interconnecting network. It forms the supporting framework of lymphoid organs. What are the lymphoid organs here? Such as bone marrow, spleen, and lymph nodes. So here nothing but reticular tissue cells secrete reticular fibers. They form an interconnecting network. It forms the supporting framework of lymphoid organs such as bone marrow, spleen, and lymph nodes. So in this picture, you are able to see the reticular fibers. Okay, go for the picture. Reticular connective tissue. So especially it is made up of reticular fibers. So it is giving a supportive framework like lymphoid organs like lymph nodes, okay, and bone marrow. This is about the reticular connective tissue. Okay. Now go for what we have learned. So today we have discussed about the epithelial tissue, simple and compound, and simple, squamous, cuboidal, and columnar. And coming to the connective tissue, proper and here this is the bone and blood. When we come to know about the loose connective and dense connective, in case of loose, areolar, adipose, and reticular tissues. So we come to conclude. So we have completed up to the connective tissue proper. Loose means that is areolar and adipose and reticular. So in the next coming class, we will discuss some more points regarding the next types of connective tissues, which are known as skeletal and blood. Blood means the fluid connective tissue. Okay. Now let us go for the assignment. Describe briefly about the three types of intercellular junctions of epithelial tissue. I repeat the question once again. Describe briefly about the three types of intercellular junctions of epithelial tissue. Give an account of glandular epithelium. The second question, give an account of glandular epithelium. Third question, give a brief account of the cells of areolar tissue. Third question, give a brief account of the cells of areolar tissue.
Hello, sir.
Good afternoon, madam.
Good afternoon.
And please share the screen, madam.
Is it okay, sir?
Okay, madam.
Okay.
Wait, madam.
Can I start, sir?
Wait for a moment, madam. Yes.
Okay.
Ready, madam?
Yes, sir. Can I start?
Moment, madam. Just a moment. Start minute.
Good afternoon, students. Yesterday this is a straight line, that is the class 3, straight line class 3. Yesterday we have seen the slope. If 2 points are given, then how to find the slope? If 2 points are given, how to find the slope? By using the formula y2 minus y1. By using the formula, m is equal to y2 minus y1 is equal to x2 minus x1, or we are using what? y1 minus y2 by x1 minus x2. y1 minus y2 by x1 minus x2. Yesterday we have seen if they will specify the 2 points, if they will specify 2 points, then how to find the slope. Also we have seen if a slope is specified, if the slope for the given line is specified, then how to find the slope for the line parallel to the given line as well as the line perpendicular to the given line. Also we have seen, what we have seen more yesterday, how to find the equation of a line parallel to the x-axis, also equation of the line parallel to the y-axis. And if one out of the two coordinates, if the out of the two points, if one coordinate is missing, that is if one coordinate is unknown. If one coordinate is unknown and slope is specified, and they have given what? They have given the slope value. Let it be some minus, let it be 2 by 3. Then how to find this x coordinate? Or if they don't say, if they specify x coordinate, then how to find this y coordinate? So yesterday we have seen all these sums, all these problems regarding these all concepts. Today we are going to deal with another concept, that is nothing but intercept. What is that? It is intercept. Intercept. What is meant by intercept? What is meant by intercept? In the given, if we take x-axis, x dash, y dash, and if I consider a straight line, L, if it intersects the x-axis at some point, let it be A, the point on the x-axis will be of the form x comma 0. Here instead of that I am taking A comma 0, and the point where it intersects the y-axis, I am considering it as 0 comma B, and this point I am taking as capital B, and this point I am taking as a capital B. Therefore, here A is called, this distance A is called what? X-intercept, and the distance this one is called, B is called the y-intercept. A is called what? X-intercept. What is X-intercept? The line the line where it touches the x-axis, where it intersects the x-axis, is nothing but the x-intercept. Here it is intercepting x at which point? At A. Therefore I am taking A as x-intercept, and B is equal to what? Y-intercept. B is nothing but a y-intercept. Why I am taking B as a y-intercept? This line L is intersecting the y-axis at the point B. Therefore, I am considering this as B as a y-intercept. So A is the x-intercept and B is the y-intercept. Depending upon the values of A and B, we can say the position of this line. Where does this line fall? Whether in which quadrant? We can say in which quadrant the line will fall. That is, if we have for if A is greater than 0. So these are x coordinate, x axis, this is y axis, and if A is greater than 0, A means x-intercept. Here we have the positive values of x, here we have the negative values of x, and here we have the positive values of y, and here we have the negative values of y. That is, here A is greater than 0. What does it mean? A is greater than 0 means A is positive. Therefore, A is positive. And B is also positive. Where here we have positive and the positive. Therefore, the line will pass like this. Therefore, the line will be like this. That is A comma 0 and B 0 comma B and B 0 comma B. For this, the line will fall in. The position of the line will be in quadrant 1. In quadrant 1. Similarly, if we take x, x dash, y, y dash and 0. Suppose here it is negative of x, that is A value negative means less than 0. If A value is less than 0 and B value is greater than 0, that is the x-intercept is less than 0 and the y-intercept is greater than 0. What does it mean? X-intercept is negative while the y-intercept is positive. Then line will be here in the quadrant 2. In the quadrant 2. If x, x dash, y, y dash, y, y dash. If A is less than 0 and B is also what? Less than 0. Here it indicates what? Both the negative axis. That is, x-axis is taken as a negative value and also B as a negative value. Then the line will fall here. Then the line will be here. That is, A is A comma 0 while B is 0 comma B. B is 0 comma B. And another condition for this is what? We have taken both as a positive, one negative, one positive, and one negative. And the next one is both as a one is a positive, that is A is greater than 0 and B is less than 0. A is greater means here and the B is less than 0. Then the line will be here. That is A comma 0 and B, what is B? 0 comma B. 0 comma B. Here it is x-axis and this is the y-axis. Therefore, depending upon the values of A and B, depending upon the values of A and B, that is depending upon the values of the intercept, that is x-intercept and the y-intercept, we can say the position of the line. We can say the position of the line. If suppose if a line does not pass to, if a line passes to origin, if a line passes to what? Origin. Then what about the x-intercept and the y-intercept? If the line passes to origin, then what about the x-intercept and y-intercept? What is x-intercept? If a line intersects the x-axis, the point where it is intersecting the x-axis, we are considering it as x-intercept. But this line is not passing through any. Here the x-coordinate will be what? How much is 0? As well as the y-intercept is also 0. Therefore, we can say that a straight line passing through the origin does not have any x-intercept or y-intercept. If a line, or also we can say that if a line does not have a x-intercept or a y-intercept, it passes through the origin. It passes through the origin. Next, what can we say? What about the lines if they are parallel? What about the intercepts? For a horizontal line, a line What is the x-intercept for this horizontal line, as it is not at all intersecting at any point on the x-axis? Therefore, the x-intercept for the horizontal line is 0. And what is the intercept of y? What is the intercept of a vertical line? Is it intersecting anywhere on the y-axis? No, it is not intersecting. Therefore, y-intercept of the vertical line is 0. Y-intercept of the vertical line is 0. So this is all about intercept. This is all about the x-intercept and y-intercept, depending upon the a and b value. Depending upon the way a and b value, how where this line falls, whether in quadrant 1, quadrant 2, quadrant 3, or the quadrant 4. Also, we have seen that if it passes to the origin, it doesn't have any x-intercept. If a line passes to an origin, it doesn't have x-intercept as well as the y-intercept. A horizontal does not have an x-intercept, and a vertical line does not have a y-intercept. Next is theorem we have, that is slope intercept form. What is the theorem we have? Slope intercept form. Slope intercept form of a straight line, slope intercept form of a straight line. Okay, what is this? Slope intercept form of a straight line. What is the statement we have? What is the statement? The equation of a straight line, the equation of a straight line, the equation of a straight line with slope m, with slope m and cutting off y-intercept C is how much? Y is equal to mx plus c. We need to show that. Okay. What they have given, what is the statement? The equation of a straight line with slope m. The equation of a straight line with slope m and cutting off y-intercept c is y is equal to mx plus c. Is how much? Y is equal to mx plus c. Then what we have? So we have a line L, the equation of a straight line. So we are taking a straight line L. Let L be the line. Let L be the line. With what? With slope M. With slope M. And cutting of the y-intercept. It is cutting the y-intercept. Let B is equal to what? Where, what is the y-intercept? Here they have specified as C. Therefore, we are taking this as C. We are taking this as C. Cutting, let L be the line with slope M and y-intercept as C. Therefore, what this line, this one, that is B point 0, C belongs to where? Is on the line L. Now we are considering a point. We are considering a point P. I'm considering a point P in the xy plane. I'm considering the point P in the xy plane. Consider P x comma y in the xy plane. I'm considering the point P in the xy plane. We know that if we have a 2 points on a line, then how can we find the slope? If we have a 2 points on the line, we have a two points, that is B and a P. Then how can we find the slope? Then slope of a line, slope of line L can be found out by M is equal to what? Y2 minus Y1, that is Y minus C by X minus 0. X minus 0. Here I am substituting the points Y minus C by X minus 0. So X minus 0 is equal to how much? X. X minus 0 is equal to how much? X. Therefore, by cross multiplication, Y minus C is equal to MX. This implies that Y is equal to MX plus C. This implies what? Y is equal to MX plus C. So we got the equation. So we got the Y equation. Here M indicates what? Slope, and C indicates the y-intercept. M indicates slope and C indicates the y-intercept. Next, conversely. Next, what we need to take? Conversely, we need to prove. If this is true, then the point P also should satisfy the equation of conversely P. If P satisfies, if the point P satisfies this equation, satisfies the equation y is equal to mx plus c, satisfies that equation, then P should be what? 0 comma c if x is equal to 0. If x is equal to 0, then what should be if x is, here I am substituting what? M into 0. So y is equal to c. So the y-intercept is c. So that point will be what? 0 comma c. Then P will be. If x is not equal to 0, if x is not equal to 0, then what about this? Then M is equal to what? Slope of L, slope of the line, which is equal to what? Y minus c by x minus 0. Y minus c by x minus 0. Y minus c by x minus 0. And that is nothing but the slope of BP. Here we have what? Slope of the line BP is also there. Therefore, slope of the line BP. We know if the slope of this line and slope of this line both are equal, then what kind of lines they are? What kind of lines they are? The lines are parallel. That is, L is parallel to BP. L is parallel to BP. But we know that L contains what? L already has B. L already has B. Therefore, we can say that what we can say? Therefore, we can say that L contains B. L and BP are the same lines. This implies what? P belongs to the line L. Therefore, we can say that the equation y is equal to mx plus c. Y is equal to mx plus c satisfies only those points. Which are on the line. So we can say that it satisfies only those points which are on the line. Therefore, we can say slope-intercept form of a line is what? Y is equal to mx plus c. Y is equal to mx plus c. So what we have done, what they have asked us, what they are asking us, that is, what they are asking us, they are asking us the equation of the straight line slope and cutting of the y-intercept p is y is equal to mx plus c. This is the statement we have. Now, we are proving. How we are proving it? That is, they have said that we need to take a line. So we have taken a line and that line should have a slope n. So we have to consider the slope as n. And it is cutting the y-axis at c. So we are considering the point where it is cutting the y-axis is nothing but the b, that is 0, c. That is 0, c be on this line. So we are considering the point xy in the xy plane. We are considering the point xy in the xy plane. Then we have 2 points on the line. Then we know how to find the slope. Therefore, the slope of the line L, that is slope of the line L is given by n. M is equal to y minus c by x minus 0. We know that x minus 0 is nothing but x. Therefore, m is equal to what? Y minus c by x. By cross multiplication, what I am getting, x minus c is equal to mx. So I am just sending this c to the other side, that is y is equal to mx plus c. Now, this is one. Again, what? Conversely, if I take all the points to satisfy this equation. Conversely, if I take a point to satisfy this equation, then if x is equal to 0, then what? P of 0, 0, c. If x is equal to 0. If x is not equal to 0, then what happens? The slope of the line, that is m, is equal to what? Slope of the BP. If the slope of the BP is equal to slope of the line, that is, if the slopes of the two lines are equal, then we know the condition that it is the condition for the parallel line. Therefore, we can say that this line L is parallel to BP. But already we know that L contains what? B. L contains what? B. Therefore, L and BP are the same lines. Therefore, hence we got an confirmation that this L and BP are the same, but not the different lines. Therefore, this implies what? This P belongs to line and this P belongs to L. The equation y is equal to mx plus c satisfies. Hence we can say that this equation satisfies only those points which are on the line. This equation satisfies only those points which are on the line. Therefore, the slope intercept form of a line is y is equal to mx plus c is nothing but y is equal to mx plus c. Hope you all have understood what is the point, what is the slope intercept form of a straight line, that is equal to y is equal to mx plus c. We will see an example or a sample problem regarding this, which is given in a textbook. They have mentioned what? Just we will have a look at the problem. Okay. If this y is equal to mx plus c is the line which has a y-intercept. If it doesn't have a y-intercept, then it passes to the origin. That is, if c is equal to 0, then the line will take form y is equal to mx. What does it mean? This is nothing but the equation of the line passing to the origin. Equation of the line passing to the origin. Equation of the line passing through the origin. Next is we are taking a problem, that is find the equation of the line. So find the equation of a straight line making an angle 120 degrees with the positive direction of x-axis measured counter clockwise and passing to the point 0, -2. What they have mentioned, we know. What is the definition of x-axis? What is the definition of the slope? What is the definition of a slope? That is angle made with the positive x-axis measured in a counterclockwise. Here they have mentioned the slope. Slope is equal slope. Slope we will take it in a tan theta. Tan theta is that is they have mentioned theta. Theta is equal to how much? Here 120 degrees. Here theta is equal to how much is the angle? 120 degrees. Therefore, m is equal to what? Tan 120 degrees. How can we find 120? That is tan of 90 plus theta. 90 plus 30. 90 plus 30. 90 plus means it falls in which quadrant? Second quadrant. We know that tan is negative in the second quadrant. Tan is negative. Therefore, we'll get what? Tan is equal to √3. Therefore, the value is how much? √3. Therefore, minus √3 is the slope. Is nothing but the slope. M is equal to minus √3 is the value of slope. And also they have given what? Passing through the point 0, -2. 0, -2 indicates what? That point lies on the y-axis. That is, they have given the intercept. That is y-intercept. They have mentioned in this y-intercept C is equal to -2. Therefore, we need to find what? Equation of the straight line. We know we have a slope as well as a y-intercept. By slope-intercept form. By slope-intercept form. That is, y is equal to mx plus c. Y is equal to what? Minus √3x less of -2. That is, y is equal to minus √3x -2. That is, √3x plus y plus 2 is equal to 0. This is the equation of a straight line. This is the equation of the straight line if they give the angle as well as the y-intercept. If they will give the angle as well as the y-intercept, this is the way we will find the equation of a straight line. We have a sums, that is take that as a homework. In exercise you have a sums. In exercise you have a sums, that is in second bit you have seventh one. Second bit in exercise 3A, second bit, seventh problem. Take it as a homework. Take it as a homework. Take it as a homework. Second bit, seventh problem. So next is what we have. Next is the intercept form. Next is the intercept form of a straight line. Next is what we have. Intercept form of a straight line. Intercept form of a straight line. Intercept form of a straight line. So what is the statement we have? The equation of a straight line. The equation of a straight line which cuts off non-zero intercepts, which cuts off what? Non-zero intercepts A and B on x-axis and y-axis is x by A plus y by B equals to 1. Equals to how much? Equals to 1. What they have given here. What they have given here. So, just have a look. The equation of a straight line. So, we'll take the So let this be the line. This is a straight line L which cuts off a non-zero intercept A and B on X and Y axis respectively. On X axis it is cutting at A and on Y axis it is cutting at a point B, that is nothing but 0 comma B. Then the equation will be formed. Which form it will take? X by A plus Y by B is equal to 1. So what we have taken, let the line, let L be the line, let L be the line with slope M, and it intersects X axis at A comma 0 and Y axis at B 0 comma B. Here X intercept is A and the Y intercept is what? Is equal to B. X intercept is A and the Y intercept is B. So we are finding what? As we have 2 points on the line, what is the slope? Slope of the line L. Slope of the line L. I am taking a slope of line L. That is equal to M is equal to how much? Y1 minus Y2 by X2 minus X1 minus X2. So I am considering that is 0 minus B by A minus 0. So M is equal to how much? 0 minus B will be minus B, A minus 0 will be A. So M is equal to how much? Minus B by A. And Y, what is the Y intercept? I have B. So I have a slope as well as a Y intercept. So can I use slope intercept form? Therefore, by slope intercept form of a straight line, that is equal to Y is equal to mx plus c. In place of m, what I have? Minus b by a x. And in place of c, what I have? C is the y intercept over here. What is the y intercept? Y intercept is nothing but the b. Therefore, I am substituting b over here. Now I need to take the LCM. Y is equal to minus bx plus ab by b. Now by cross multiplication, yb is equal to what? This is a by a. So by cross multiplication, a into y is equal to minus bx plus ab. Just take this term to the other side. Just take minus bx to the other side. What I'll get? So what I'll get? That is bx plus ay is equal to ab. Bx plus ay is equal to ab. Now what I am doing? I am dividing throughout this equation. Dividing throughout this equation by AB. So bx plus ay by AB is equal to AB by AB is equal to what? AB by AB. What I'm getting? Dividing this equation throughout by AB. So I'm getting bx plus ay by AB is equal to AB by AB. So individual dividing. I am dividing it individually. That is bx by AB plus ay by AB. As AB gets cut off, I'll get 1 and BB cuts, AA is cutting off. So what is left? X by A plus Y by B is equal to 1, where A and B are the x-intercepts and the y-intercepts respectively. X-intercept and the y-intercepts respectively. Therefore, if they specify x-intercept and the y-intercept, how to find the equation? This is the way we will find the equation, that is x by a plus y by b is equals to 1. X by a plus y by b is equals to 1. So what they have given, just see one. What is, how to find the intercept form of a straight line? What is the theorem? The equation of a straight line which cuts off non-zero intercepts a and b. Non-zero intercepts a and b on x-axis and y-axis is x by a plus y by b equals to 1. So we are considering a line L with slope m and it intersects the x-axis at a, that is a comma 0 and b at 0 comma b. This implies what? X-intercept is a and the y-intercept is what? Y-intercept is equal to how much? Y-intercept is equal to b. Now, slope of the line L. Now, what is the slope of the line L? Slope of the line L is equal M. M is equal to what? Y2 minus y2 minus y1 by x2 minus x1 or y1 minus y2 by x1 minus x2. So I am applying that 0 minus b by a minus 0. So m is equal to how much? Minus b by a. M is equal to how much? Minus b by a. This is the m. I have a slope as well as the y-intercept. I have a slope as well as the y-intercept. So we have just now we have to, what is the, we know the slope-intercept form of a slope-intercept form. So by slope-intercept form of a straight line, that is y is equal to mx plus c. What is the slope-intercept form of a line? Y is equal to mx plus c. We are in place of m and substituting minus b by a, and in place of c and substituting b. Therefore, y is equal to b. Now I'm taking the LCM. What I'll get? Y is equal to minus bx plus ab by a. Y is equal to minus bx plus ab by a. And by cross multiplication, what I'll get? Ay is equal to, by cross multiplication, what I'll get? Ay is equal to minus bx plus ab. Minus bx plus ab. Now, what I'm doing? I'm dividing throughout this equation by AB. So, what I'll get? BX plus, I'm taking this term over here, BX plus AY is equal to AB. That is BX plus AY by AB is equal to AB by AB. That is by individual dividing, what I'll get? BX by AB plus BY by AB is equal to 1. That is BB gets cancelled, AA gets cancelled. What I'll get? X by A plus Y by B is equal to 1. This is nothing but the intercept form of a straight line. This is nothing but the intercept form of a straight line. We'll see a sample problem regarding this. We will see a sample problem regarding this slope intercept form. If they'll give the intercept, how to find the equation of a line? How to find the equation of a line? How to find the equation of a line? That is the equation of a straight line which makes intercepts whose sum is 5 and the product is 6. They have not mentioned x-intercept and the y-intercept directly, but they have mentioned it through some conditions. They have given the conditions as the sum of the intercepts is equal to how much? 5, and the product of the intercepts is equal to how much? 6. They have mentioned the conditions that if suppose if A and B are the intercepts, if A and B are the intercepts on x-axis and y-axis respectively, then by hypothesis, that is by given, then by hypothesis, that is what is mentioned in the given problem. Hypothesis means, that is what is mentioned, the sum is equal to how much? 5. That is A plus B is equal to 5. And the product of the intercepts is equal to how much? And the product of the intercepts is equal to how much? Is equal to 6. And the product of the intercepts is equal to how much? 6. And the products of the intercepts is equal to how much? 6. So based on this, we need to take if from this conditions A plus B is equal to 5. This implies what is A? A can be written as 5 minus B. A can be written as what? 5 minus B. Now substituting in place of A, 5 minus B in this equation. Now substituting in this one, in this condition, and substituting A is equal to 5 minus B. That is 5 minus B into B is equal to 6. That is 5B minus B square is equal to 6. 5B minus B square. As here I have the equation in B square. Here it is a quadratic equation in B. Therefore I am taking all the terms on the left hand, on the right hand side, so that square term is degree 2 term will be positive. So B square minus 5B plus 6 is equal to 0. Now taking the factors, now solving the quadratic equation. That is why we need to take the factors. So 5, how will get B square minus 3B minus 2B plus 6 is equal to 0. Minus 2B minus 3 is equal to how much? 0. So what I'll get if I take common, if I take what B common from the first two terms, B minus 3. If I take minus 2 common from the second two terms, I'll get B minus 3 is equal to 0. Hence I'll get, if I take from this B minus 3 common, what I'll get? B minus 2 is equal to 0. B minus 2 is equal to 0. So B minus 3 is equal to 0. B minus 2 is equal to 0. So B is equal to 3 and B is equal to 2. Therefore, what can we find? If B is equal to 3, then what about A? A is equal to how much? 5 minus 3. That is equal to 5 minus 3. A will be how much? 3. Therefore, the equation of the line, that is x by A plus y by B equals to 1. Substituting A is equal to 2, x by 2 plus y by 3 is equal to 1. Now taking the LCM, what I'll get? 6 as the LCM. That is, here I'll get 3x plus 2y is equal to 1. If I cross multiply it, I'll get 3x plus 2y is equal to 6. And if I get this 6 over here, it will become minus 6. 3x plus 2y minus 6 is equal to 0. This is the one if B is equal to 3. Now, I got two values for B, no? That is 1 is 2.
Kindly close the session, ma'am.
Oh, okay, sir. Just a few seconds. If B is equal to 2, then what about A? A is equal to how much? 5 minus 2. Then A is equal to 3. Therefore, the equation of the line is x by 3 plus y by 2 is equal to 1. Take the LCM. I'll get how much? 6. 2x plus 3y. 2x plus 3y is equal to 1. That is 2x plus 3y is equal to 6. 2x plus 3y minus 6 is equal to 0. Therefore, these are the equations of the straight lines. If they'll give A and B, they'll give intercepts. Similar kind of problems you have in exercise with the conditions. So kindly do that. Thank you so much.